Bismillah ar-Rahman ar-Rahim, students. Welcome back. June 2025 and 33 variant complete pure paper. We are going to start now. Question number 1 is a sketch and A is a positive constant. So how to do it? Okay, so best way we will get this. Just a minute. Okay. And all right. So we will make a table. And what is the best way of making table? Inside the modulus, whatever you will put is equals to 0. And try to make x subject. And x becomes 2 over 3 times 2a. So now what I will do, students, I will take any three numbers randomly. But best number is this one. This one I'll put in the middle. So I'm going to put it here 2 over 3a. One number before this, which is ideal, is 0, and one number after. You deal a like a 1, okay? Deal a like a 1. So 2 by 3 is 0 point something. I take after, let's say, 2, or let's say 3. If I take, and just a minute. Okay, wait a minute. This is 0. Sketch 3x. I got a 2a. X, this is basically, when I plug in x value 0 in the place of here, I got a negative 2a. Look, I'm showing again. I put 0 here, I got negative 2a. And negative 2a modulus is 2a. 2a. So it means x is 0, y negative, positive 2a. So if I assume a here and here 2a, so this is a point. When I plug in this value in the place of this x, okay, so this will give us 0. So where is 0? 0 is here. But 2 by 3 is, if you check in decimals, it is approximately, if you check it, 2 by 3 is 0.667. So not even 1. So this is a 1, this is a 2. This I mean to say a and is a 2a. So this is a number is somewhere here. So I take it here. Okay, these 2 points I can join easily. Very clear idea. Okay, now I need one more number. How to make it one more number? And more number after that. For example, I take 2a. When I take a 2a, so let's try to plug in 2a in the place of x. So when I plug in 2a in the place of x, so I got a 6a minus 2a, I got a 4a. So 4a is this is a 2, 1, 2, 3, 4. So somewhere on the top. Random, I'm taking number here on the top. So it means 2a and 4a. So here I got a 4a. Here I'm getting here 4a. So yes, exactly. So it means I take a number on the top, because roughly, this is not a neat diagram. This is a sketch. So I believe the point is very clear how I got it. So part B, students, we have modulus one side available and modulus second side not available. Okay, but basic rule is what? If x involved on both sides, we're squaring both sides. So if x involved on both sides, we must square. So 3x negative 2a whole square less than x plus 5a whole square. So first term square is 9x x square, 2 to the 4th is 12ax and plus 4a square. I'm open squaring identity. So this is 2 5s are 10a and plus 25a square. I bring all values left side. Out of 9, this one gone. I got 8x square. This added, I got negative 22ax. This subtracted, I got negative 21a square. So I can go for factorization. I have two choices, students, factorization or quadratic formula. So if I go for even the formula, even no issue at all, but make sure when you are applying quadratic formula, you must write here. So I'm using quadratic formula. So because there are two variables we have, okay? Or I can apply even a factorization even. 8 ones are 8, 8. Okay, or I give you another way. If you divide whole equation with a, whole equation divide with a square, what do you get, students? X square by a square, and negative 22 x by a, and negative 21 and equal to 0. So this way you got a variable x by a. You can see x by a. Now applying quadratic formula. Negative b, minimum, this step you have to show to examiner. For a is c and this is 21a square. Okay. 21a, sorry. A square gone basically. Basically a gone. Okay, 2a. If I apply the formula, what I'm getting two answers. First answer I'm getting here in negative 3 over 4. Negative 3 over 4. And second answer I'm getting here is x by a 7 over 2. Now students cross multiply a multiply there and I talk about less than. So I have to check it, which is a positive, and now multiplying there. I'm saying here negative 3 over 4 times 2a. And here I got 7a by 2. And look at now, I'm going bell shape. There's a lesser means inside. So smaller number is this. I'm writing negative 3 over 4a and positive number is 7 by 2a. So my answer is turned to be this 7 by 2a and more than negative 3 over 4a. But hold on, now we can check it because I said before, we are bound to check it. This sometime one answer we have to remove it. So that reason I have to make it the right hand side a table for right hand side. I will make a table for right hand side. Check it please. 3 numbers or I think 2 numbers enough for it because there's no modulus. So no turning point, no turning point. It's a straight line only. So best numbers are any numbers 2 I can plug in. So if I plug in, for example, in the place of x, in the place of x, I plug in here, let's say, because equation is y is equal to x plus 5a. So if I plug in the place of x, let's say negative a, I put negative a. Negative a is best number. Negative a, I got a positive 4a. Why I'm bringing this number? Check it please. Negative a is here and 4a is here. This is a 4a basically. So 4a. So we are getting this point somewhere. So this point is coming from here. Another number I can plug in, which is a negative, I think so. Negative 2a, if I plug in, I think this is better. Negative 2a, plug in the place of x, I get a 3a. So negative 2a is here, negative 2a is here, and positive 3a is 1, 2, 3. So this is a 3a. So I got this point. So I got this point. Now, students, I'm going to sketch. Okay, just draw. Okay, you can see from here when I draw this one. Okay, sake of understanding, this is I just make it line here, and now I can show you what I'm going to show here. Finally, here this equation is and cutting the green color line already here. Okay, now you may ask one question. It is a very clear look at now. There's enough evidence for, or you can make a diagram smaller and show a little bit this gap is reducing. It means this black line will cut the previous diagram at 2 points, one here and one somewhere after that. So it means both answers are coming in our range. One answer is coming negative, you can see clearly, and one number is positive. If I zoom out, I will get the diagram like this. Look, I'll show you. Hold on. Zoom out if I show you. So the second line will be like this. It is like this, and they will intersect like that. So one number is negative and one number is positive. So I hope so. The concept is very clear. And if you make this diagram little zoom out, so this is better to show the examiner. Okay. Second part, examiner will not ask you justify the answers. He just need to see his answer because marks are 3 only. This is just for yourself. Even you don't show this black line in diagram, no problem at all. This is just for your own satisfaction. I hope so. The point is clear now. Question number 2, students, we have we have to solve it. Okay, did not mention exact or whatever. Okay, we have a logarithm. Some student try to cancel log like this. Impossible. Why impossible? Before logarithm, we need no number. We don't need number. But here we have a number. So I will bring this 2 in the power. So when I bring in a power, it will turn to be this form. Negative log, this is the first property of logarithm I applied. Rule is any number before logarithm can go in the power of function after logarithm. So the negative sign, I can divide them. So 2x plus 3 whole square divided by 2x plus 5 equals log of 3x. Now I'm eligible to cancel log from both sides. Now I'm going to expand the power 2 on the top. Squaring identity, first term square is 4x square. Second term square is 9. In the middle, 2 into first term into second term. So 4 3s are 12x. Here, here this 2x plus 5 will multiply with that. So we got a 6x to power 2 and plus 15x. Okay, I can bring it now, all values left side, this comes this side. I'm getting here negative 2x square, negative 3x and plus 9 is equals to 0. Multiply by minus 1 is not compulsory. If you do it, good for you. If you don't do it, no problem at all. So 9 2s are 18, 9 2s are 18, and 6 3s are 18. Let's see, 6 3s are 18. So we can factorize to 2x common. I'm getting x plus 3. Here negative 3 common. I got x plus 3. And now we are going to simplify further. X plus 3 and 2x minus 3 is equals to 0. And if we look at carefully, we can get the answer easily. And first time x is this equal to 0. And secondly, this equal to 0. And I'm getting negative 3 answer and positive 3 by 2. Check it now, which is possible and which is not possible. So, so we will check it carefully here. So negative value is maybe not possible. We will check it on top. And yes, exactly, log of the 3x. If I plug in negative 3 and log of 3x here, what happens? This give you log of negative 9, which give you undefined. So this is not possible. And we got this answer. I hope so. The concept of the question is completely clear. Question number 3, students, we have, do you know, student, we have directly two integrations available only. Sine integration is cos integration is sine, and one more we have available, and that is a secant square integration is tan, okay? But cos square integration directly not available. Then what is the technique to do it? We have a way only, and that is we have a formula. You know, remember cos double formula, we have two formulas available. If you remember, one is 2 cos square x minus 1, and this half angle will come here. So this is a formula available. So it means if I have here, we have here, for example, I just show you, if this double x, it may have become single x, or if we have a single x, we can say here double x. If we have a 5x, here we have a 10x. If we have a 3x, we have a 6x. So for example, if I ask you that if we have here 2 cos square 5x. So what we can write now, I can write here this 5 multiplied by 2, I got a 10x, and check it, half angle is here. I believe you're understanding very well, and now I can continue because cos square 5 is match. So I will try to make a subject, so this one will add. So 1 will come this side, 1 plus cos 10x, and 2 will divide, and I will get cos square 5x. Now check it, student, this cos square 5x is totally match. So 3 is already available. This complete value, I'm bringing it here. 1 plus cos 10x and divided by 5 and put in a bracket, and question is ready for integration now. Okay, and dx here. And now this number 3 and 5 will go outside, make question easier. 3 over 5. And I'm writing finally here 1 plus cos 10x and dx. And limit is pi by 5 and pi by 4. I think this point is clear. Now integration, what is integration of 1 become x and cos becomes sine 10x divided by 10. And limit is very clear, pi by 5 to pi by 4 and 305 outside. Okay, student, after this, what is the next? Next is, I'm going to apply, 1 minute, let me check here. This is 5 and let me check this 5. This is a 2, sorry, this is a 2, not 5. Sorry to say, this is a 2. This is a 2, not 5. Okay, so there's a 2 students, so 3 by 2 goes outside. Now I can continue, students, easily plug in the values. When I plug in the values, when I first plug in this pi by 4 here, I get a pi by 4. And when I plug in pi by 4 here, so please, he asked the exact answer. So do one favor, upper part type separate, okay? Sine 10 times 2 pi divided by 4. And if you check it in calculator, so this pi by 4 comes where? So we get a 10 pi by 4 is coming 1. So this is coming 1 and 1 by 10 minus. So once again, I just recheck 10 pi by 4. Yes, correct. Okay. So done. Now, when I plug in the upper lower limit now, student, what happens then? So I'm going to get in the bracket pi by 5 and pi by 5, this can just sine 2 pi and that is 0. That is 0. And now then I'm going to expand the bracket. So pi by 4 plus 1 by 10 negative pi by 5. I can take LCM inside, 3 by 2 outside. So what is LCM inside? Or you can take LCM. LCM is not wrong, even correct, okay, but best idea, you can simplify and make the numbers separate, these two numbers. So if we check it, 104 and minus 105 give you 1 by 20. So I'm getting here pi by 20 and plus 1 by 10. Now this multiply inside. So I got a 3 pi by 40 and 3 over 20. And this will give us the final answer. You can take LCM also and regret that form. So both forms are acceptable. So I hope so. The concept of the question is very clear. Question number 4, students, we have, and we have given here complex number Z1, Z2, two complex numbers given, students. Show this format. So what is the way to do it? Star stand for conjugate, you know it very well. And if I take the conjugate of both, what is the way? Conjugate has effect on, if you know very well, students. If I say that I have a R1, just sake of understanding, cos theta 1 plus R2 sine theta 1. Sorry, why R2 I wrote here. So iota I actually want right sine theta 1. So this is a expansion of this form. So exponential form convert to Cartesian form. So this is a clear. So you know conjugate will change the sign of this only. So basically it means if I convert it, so star will be the sign of this will be change only. Make sure. And interesting part what we have. If I replace if I replace here, for example, just sake of understanding here, negative iota. So what will happen, students? So basically, if this negative sign, I can show you now. So if negative can go inside and I get here iota sign of negative theta 1. So for your information, a sign, if I have a sign inside or sign in the bracket, so in negative theta, both are exactly same. But in case of cos negative theta, what is solution, students? Negative eliminates automatically. So this is concept is very must be clear. So it means that it means you can replace here negative theta 1. So sake of understanding, we can say that the conjugate is what? So this is, look at the sign negative. So if I combine back in this form, exponential form, I can say that it tends to be iota, negative iota theta 1. So because there's negative and negative, that is the logic behind it. So I think you got a point. So that is why I can say directly without any hesitation what is the conjugate of this one. So I'm writing directly now. Z1 conjugate is equals to R1 E negative iota theta 1. And what about the other one? Z2 conjugate is R2 e to power negative iota theta 2. I just plug in negative there. I think you people understanding very well simple criteria, and I given an idea behind the scene. Okay, so this I'm erasing it now because space problem, otherwise I can leave for you for future use anyway. So you can rewatch this recording once again if you want to check the formulas. So now student, what is the technique here? So this both values we have, I'm going to multiply. So Z1, Z2, both conjugates going to multiply. What's rule of multiply, students? The modulus will multiply outside R1, R2, and this will add like a logarithm property. They will add. Even add, okay, negative iota theta 1 and negative. Basically, I'm adding, okay? So negative into positive negative. So this turned to be this. And finally, I can say R1, R2. This is I can combine it, iota and theta 1 plus theta 2. So this I got Z1 star and Z2 star. This is very clear. Now he's asking that we have this, okay, a product. So he said this is the same answer. So I have two ways I can I have taken this right hand side and I'm taking here left hand side. Okay, left hand side is this one. So first I multiply them Z1 times 2 Z2. So basically I'm doing the same process, but here R1 e to power iota theta into R2 e to power iota theta 2. Okay, so clear. Now Z1, Z2 students we can say is turned to be R1, R2 because they will multiply and here powers will add iota theta 1 plus iota theta 2 and I can take common out. So I got iota and theta 1 plus theta 2. This is clear. Z1 and Z2. And if I take a conjugate of the whole complete, okay, like this, what have R1, R2, no change, but according to formula, I will get negative outside, and I hope so. You understood very well, and both sides are matching. They match. We can say that. So hence proved. Hence proved because they are totally matched. So Alhamdulillah Rabbil Alameen, this part is very clear. So let's talk about the lower part. Lower part, he said that one complex number is a root of this equation. So this is given one complex number. And you know very well, whenever one complex number given, what is second root? But I have to open it just for your understandings. 3 outside and cos pi by 4 plus iota sine pi by 4. If I type in calculator, so what I get, even type this together, okay, you can check in calculator root 3 by root 2 by 2 basically. So I'm getting here Z, this I call it a Z basically. So if we check it, so root 2 by 2, okay, so 3 times to root 2 by 2, we get it here. And same story here. Okay, we got a 3 root 2 by 2 and iota. So this is a first basically make sure whenever we have a one root is given of a power 2 quadratic equation, second is always conjugate. So other root is 100%, we can write this one. So 3 root 2 by 2 negative 3 root 2 by 2 iota. Sign will change only. Or I just taught you previous part. So put a minus sign with a pi by 4. So it means I can say 3 e to power negative pi by 4 iota. So you write this form or this form. But for the next part, I need this form. That is why. So next part is asking get the values of BC. Students, for your sake of information, I just tell you, if we have a equation, a quadratic equation, what does this B stand for? Let me tell you, B stand for sum of the roots. And what does this C stand for? It's called product of the roots. It means if I find the sum of the roots, if I add them both, what happens? This both will cancel out and I get what? I get this plus this. So I got a 3 root 2. Okay, I just sum. And what is a product is coming with us? Product is this both multiply each other. And multiply, students, a plus b times to a minus b. What is answer? Square of a minus square of b. So look at first term same, correct. Second term same, correct. Sign opposite, correct. So square of the first and square of second. I'm doing it like this. So square of the first term and square of the second term. You can, if you want to do a longer way, you can multiply them even, no problem at all, but it took a lot of time. So now 3 square 9 into 2 over 4. 3 square 9 into 2 over 4 and into minus 1 because iota. So I'm getting here 9. So this positive, so it means I'm getting 9 here. If you check it again, it's turned to be 9. So basically this is a sum of the roots. So this is sum of roots. So B value, so we can say that. So B value is 3 root 2. An important part. What is the important part, students? Important part is formula. Basically, we have like this. Look, I'm writing for you. Z square minus sum of roots time to Z plus product of the roots is equals to 0. So now basically, if you look at carefully, if you add them, okay, so this negative sign must be there. But that negative sign is there, so we have to introduce here negative sign. There's a very important, so that is why we are getting negative, and C value is 9, and I hope so the concept of the question is clear, but I repeat it once again. So when we have a formula, we have z square minus sum of root time to z and plus product equals to 0. So sum I'm getting from here is 3 root 2. But when I plug in there, so basically this is a negative sign. But if there's no negative sign, it means this value must be negative. So negative into negative will give you positive. This is a logic behind. I hope so. The concept of the question is very clear now. Question number 5, students, we have topic is differentiation, and we have to convert in this form. So let's try to do it. So first of all, product form. Product form, you know very well. U copy V derivative, V copy U derivative. And say, what is this one? X copy. So Y derivative is dy over dx. Now Y copy, X derivative is 1. Afterwards, now I'm going to apply it here. So y square copy an exponential derivative inside, then exponential copy and y square derivative here, and 4 becomes 0. And what is exponential derivative? First copy as it is into power derivative minus 1. And what about y square? 2 comes down and power become 1 less into y differentiation, which is dy over dx. Now we have a 2 dy over dx. We have to make them on one side. So first of all, what I'm going to do, yes, okay. So I'm going to take common out, dy over dx common out. I get x from here and I got a 2y e to power negative x. So this is common, I think clear idea. And these two values I'm bringing on the other side. So this negative will become positive. So I'm getting e to power negative x into y square. And this minus 1 become positive and minus y. This is done, students. So now dy over dx, this whole thing, basically you can see that power is negative, but he is writing positive. So some reason behind, I will solve this issue. Just wait. Y squared negative y and x plus 2y e to power negative x. Okay. I think clear. Now, student, if you check the solution, what is the need there? You can, with beside of y square, we have e to the power minus, but beside of y, nothing. So can I divide the numerator and denominator both y e to the power minus x? Why not? Repeat my words. Beside of y square, we have e to the power minus x, but here nothing. So I need 1. So this I have to eliminate. So I have to divide. Look, I'm showing what is the way of dividing. Fractions. So e to the power negative x y square divided by e to the power negative x. And y divided by e to the power negative x. Not only numerator, even denominator. Same process. This is a rule of algebra. Now, students, I'm going to finalize it. You know, where this cancel out, this cancel out, and we are close to answer. How to get it? This y square comes confirm, but this will go up. When go up, power sign changes, and I'm getting y time to e to power x. And this is goes up and e to power positive x. And here I got 2y. So alhamdulillah rabbil alameen, the target is achieved. Part next, find the gradient of the tangent when x is 0. We have to plug in. Where's x is 0? Thing is that if I plug in 0 here, but it's not useful, we have to plug in y as well. So we have to do, first of all, check the y. So when I plug in x here, so wait a minute, please, wait a minute. So this equation cut from here and bring down. Okay, now I'm putting here x0. When I put x0, this becomes 0, y square as it is, e to the power 0 is equals to 4. And something to the power 0 is 1, I got a 4. And I take a root of the both sides, I get a plus and minus 2. But check on top, did he mention something here? No, he did not specify anything here. So we have to go for, it's a gradients. It means two y values. So we got a x0, y positive 2, x0, y negative 2. Now I'm going to replace in the equation. Okay, so get ready now. So first of all, I'm putting 1 by 1. So 0, 0, and 2. So gradient. So when I plug in 0, 2 value here, I got a 4, 0 here. So 0 is something for 0 is 1 and 2. So 2 here. Then I plug in 0, full gone. When I plug in 2 here, 2 to the 4. So I'm getting gradient 2 by 4 half. So let's try the other number, 0, negative 2. So again, when I plug in 0, only the thing is down 0 only. And negative 2, it means it giving us this again 4. But negative 2 here, it giving us positive 2. And when I plug in 0 has gone, so negative 2 here, I got a negative 4. So gradient turns to be 6 by negative 4. So 2 threes are and 2 twos are. So I got a 2 gradients. I hope so. The concept of the question is completely clear. Question number 6, students, complex number. And we have given here that complex number z, it has real. So it means complex number of z for which this part is real. Real means imaginary part is 0. So imaginary part is equals to of z is equals to 0. Okay, and second number given this one, and we have to give answer in this form. So if I assume this z, so z is given here. So I can say here z is equal to x plus iota y. If I find out is that modulus is a very clear. So is z modulus is root and x square plus y square. Okay, and this modulus removed by root 10. So I got root 10. So I get a squaring both sides. I got x square plus y square equal to 10. Equation number 1 done. Now we have to go for the second part is here we have. So this one. So let's try to do it. Z plus 4 over z plus 4 iota. So first of all, I'm going to replace z value, and z value is very clear. So I'm writing x plus iota y plus 4 over x plus iota y plus 4 iota. And I have to simplify first x plus 4 real part and iota y complex part. And here real part and the complex part is y plus 4 and iota outside. Now I'm going to rationalize now. So rationalization process you know very well. So I just keep as it is, only sign change beside of this sign only change. So I think idea is very clear. Okay, now I'm going to multiply as rationalization process going to complete. So down part, I can say that square of x, because basically we square numbers and square is number, and like a square of the first number minus square of the second including iota. So y plus 4 and iota outside. So down part we can solve first x square negative. So how to solve this one? So basically y plus 4 whole square and into iota square. Iota square, you know it very well, we can minus 1. So upper part I'm doing later, and first of all concentrate here. So I'm getting here first term square, and this is negative, negative, positive 1. And I think I can remove the bracket also. Y square plus 8y and plus 16. This is done. I got a denominator, upper part. So upper part, student, what is the way I'm going to multiply? So x multiply both. Yeah, I get it here, x square plus 4x. So this is done, students. And what about this part? So basically, we have, because he said that this is a real part, so imaginary part is 0. We'll take only imaginary part equal to 0. Okay, this multiply with this multiply with this. Okay. So now I'm going to multiply with this. So I'm writing now here what negative sign x plus 4 times to y plus 4 and iota. Basically, this I multiplied and this with that. Okay, done. And now what this? So I'm writing here plus xy iota. And finally, this into this. So I'm getting here negative y times 2y plus 4 into iota square, which is a negative 1. So I'm just changing the sign only. So this is done. Now, students, I can save my time. How I can save my time here? Because I will take only imaginary parts, because real part is this one, clear, and imaginary part means this and this. So basically, when we have a x plus iota y over k, example I give you. So x by k plus iota, y by k time to iota. So this is called imaginary part. So which I'm going to plug in 0. So I will take iota part from top only. Iota part is this, iota part is this one, but divided by this whole thing. So that is why I think we can save our time now. And I'm saying the statement here as imaginary part is equal to 0. So I'm going to do what, students? I'm going to equate here. I'm going to equate here imaginary part. Imaginary part means I'm going to write now these two values only. So I'm writing here xy and negative x plus 4 into y plus 4. And I'm eliminating iota. I'm not wasting time. And these are real parts gone. No need of writing anything here. So this is I'm multiplying. I'm getting here xy. I'm getting here plus 4x plus 4y and plus 16 and equal to 0. So I think we can see here this is done. And I think this part will multiply 0, so no need to waste time in denominator anyway. So we got experience now in xy minus 4x minus 4y minus 16 equal to 0. Cancel out and divided by negative 4. So I'm getting here x plus y plus 4 is equals to 0. So now I'm going to get here two equations. You can see clearly. And now we am going to solve them simultaneously. Okay, so and inshallah we get our answer. So how to solve them? So I'm going to make a x subject or y subject from here. So I'm going to make a x subject or even y, no problem at all. So I'm getting 4, -4, -x, -4, -x. So this value of y I'm going to replace there. So put in 1, put in 1. So x square as it is, and y square I'm writing 4 minus x, 4 square equal to 10. Done. Now students, you know, I said many of my previous lectures, even if you expand a plus b whole square identity or negative a negative b whole square, and they are same. So no change, because this negative common out. If I show you once again, negative common out, I put square on top. So power 2 -1 eliminates. We will get a, sorry, common out. So we get the same thing. So it means both scoring identity same. I'm applying here now. So first term 16, positive 2 4s are 8x and plus x2 power 2. 10 comes this side. I got 2x square plus 8x and plus 6 is equal to 0. Divide by 2. I'm getting here 2 4s are and 2 3s are. I'm going to factorize now. So I think it is easy to factorize now. So I'm getting x square plus 3x and plus 1x plus 3 is equal to 0. I take common out x plus 3 and 1 common out x plus 3. I'm getting here two answers. X is -1 and x is -3. And how to get y? Nothing hard, but plug in this value here. I get here, when I plug in -1 here. So I'm getting here, negative, negative, positive. So -3 comes. And when I plug in -3 here, so minus plus, I got a -1. So basically we're looking for the complex numbers, and complex number is z. Z is x plus iota y. So answers he asking for. So I think clear, I'm writing two answer. So x -1, -1 -3 iota. This is my answer number 1. Second, z equals to -3, -1 iota or iota only. So I hope so. This is a little bit lengthy, but I hope so. The concept of the question is very clear, and we have done it. And let's go for next question. Question number 7, topic is differential equations. So, and first of all, every time check it. Highest power of x in the numerator is 1, and x into x is x to power 2. So this is proper fraction. So we have to no need to divide. We can start directly. But make sure if upper power is bigger as compared to like 3 up and 2 down, or even up and down equal. So we will have to go for long division for to make it in proper form. So we can start directly without any hesitation. So 3a plus 2x and 2x minus 2a minus x. So what to write? Because power, both are x as 1. They're called linear powers. So we write a over 3a plus 2x and b over 2a minus x. After this, I will multiply whole expression with this. When this will fully cancel out, and we get a 3a minus 5x. And when I multiply with this, so this cancel with this, and this will stay beside of a. And when this multiply with this cancels, and remaining part with beside of b is 3a plus 2x. So first time I'm going to do what? We have two denominators. One by one, we put equal to 0. For example, when I plug in this equal to 0, students, so what I can do now, you can see if I plug in this denominator is equal to 0, so I get 2a minus x equal to 0. I got it from here. X goes there, it means x is equal to 2a. So I replace whole equation 2a. So when I plug in x is 2a, so I'm getting here, this is a 10, and I'm getting here out of 10, 3 gone. So negative 7a, negative 7a. So when I plug in 2a here, because I kept this equal to 0, so this is gone. is completely gone. Basically, I kept this part equal to 0. This is the reason behind. And when I copy this 2a here, so what I'm getting in the bracket, 2 2s are 4, 4 plus 3 is 7a. And finally, b value, the 7a cancel out, I get -1. So I think this part is very clear. We have done one part. Now I'm second number. I'm going to replace second part equal to 0, students. And second part equal to 0 means this part equal to 0. Okay, I'm going to write the second part as well. Get ready. So 3a plus 2x is equal to 0. And 3a goes there, -3a, so x value is -3a divided by 2. So first I kept this one, and now I'm going to keep this value in the place of x. Okay, so when I replace this value, so what I get, hold on, 3a is already available. There's a plus 5, 3s are 15 divided by 2, and we are getting here 21 over 2a. And when I plug in this value here, what happens, students? So 2 and plus 3 over 2, I get a 7 over. So a is already there, and 7 over 2a. And because this I kept already, this kept I already equal to 0, you can see. So this is gone. So I'm writing here b time to 0. And now see this 2 to cancel out, 7 goes down, 3 comes. So we got a BA value 3. Okay, let's talk about the next part. Completing done. I'm going to plug in both values back in equation. So this equation completely I'm going to take. And it's compulsory to show the answers here. I'm plugging back. So when I plug in A value is 3 and B value -1. So I believe the first part is completely clear. Second part, what is asking for? He said expansion, okay, until including x to power 2. So we have to expand maximum x to power 2. So x power 2. So what is the technique now? What is technique? We are bound to have here, first of all, I think I shift whole equation on next page, because I need a, okay, here. Student, how to apply rules? Rule is 1. We need here 1 plus 1. Sorry, not here, plus 1 here and plus 1 here. So we are bound to take common out. Basically, formula is what? 1 plus b to power n. 1 plus nb, n plus n into n minus 1 over 2 factorial into square of b. So this is only applicable when we have a 1 here and plus 1, not even -1. So I'm bound to have a plus 1. X I will not disturb. So when I take a 3a common, students, the 3a common. So here I got a 1, but 3a is not present here. So 3a will go under 2x. Same story, this negative into positive negative. And I'm writing now here, same 2a common out. I get a 1 minus x over 2a. So I hope so this part is very clear. Now I'm bringing it up, this up and this up. And then I will apply formula. 3 cancel out, 1 by a, and 1 plus 2x over 3a power -1, and 1 over 2a, and 1 minus x over 2a to power -1. So students, I hope so this much is clear. This is the most important step because students mostly do mistake at this level especially. So this is done. Now I'm going to apply one by one. I call this equation number 2. Okay, or equation 1. So I'm going to do one by one. First, I'm going to solve this one. 1 by a, 1 plus 2x over 3a, and power -1. What is formula I wrote on top? 1 plus nb, and the formula is clear. So 1 plus nb. So 1 minute. 1 plus nb. N is a power, b is this. So n is minus 1, b is 2x over 3a. And what is next? N into n minus 1 over 2 factorial into square of. So I'm simplifying 1 minus 2x over 3a. And this will cancel out, and I got from here 4x square over 9a square. So this is done. Now I'm going to do the other one, which I'm going to copy the full thing from here. I think I'm missing one part, students. What is missing one part? 1 by a is missing. So I have to drag slightly out and multiply 1 over a. Okay. Now when I multiply 1 over a, students, what I get? I'm getting here, this is 1 over a, but is a power increase. So this become 3 power. I just repeat again, 3 power. So I think the point is very clear. So let's talk about a second part. So, and second part. So negative 1 over 2a, 1 plus nb. N is minus 1, b is negative x over 2a. Plus n into n minus 1 over 2 factorial into square of negative x by 2a. And after that, I got this plus x by 2a. This cancel out, and I'm getting x square over 4a square. And then I'm multiplying this, negative 1 over 2a, negative x over 4a square, and negative x square over 4 2s are 8a cube. Now, student, what to do after that? Because just adding that. When you add that simple, adding mean I do directly after adding what I'm getting the answer. Basically, this and this when I add. So if you, this is disturbing, so you can just type like this, 1 from there and negative half from there, a outside. But or not a up outside, but down. Or you can do directly even, no problem at all. So it becomes 1 by 2a. And now I'm going to do this part. You can see there's a match. So keep x over a square aside, and negative 2 by 3 and negative 1 by 4, you can type in calculator. And we are getting negative 11 over 12 x over a square. And last part, same here, x square a cube, x square a cube. Keep aside 4 divided by 9 minus 1 by 8. And answer is turned to be 23 over 72 x square by a cube. And this is my final answer. So I think this part is, students, very, very clear. And now we have to go for last part of the question, state the set of values. Expansion is validity. So valid, how to check the validity, students? Best way we have to check it, especially these two fractions, which is available. Number one is inside here and here. So I'm going to what is the math? We to try it. So the variable beside of it, like you can say that this must be, look, I first of all show here. So 2x over 3a modulus, this must be less than 0. So if I make x modulus here, because all these are numbers, so numbers I can bring outside. I got this 3 by a, this one, and modulus x left here. So I think clear. I'm sorry, not 0, less than 1. Sorry, less than 1. So why less than 1? I just tell main reason is why, because not 0, 1 we have to take, because it is also always possible if it's middle of 1 and minus 1. So that is why collectively it's called modulus. That is why. So this 3 multiply with a 1 that side, we got a x modulus, 3a up and 2 down. So this is my first validity. Second one, I took from here. And even that one I can take, and that is the 2x by 3a. Sorry to say, there's another one I take now. So I'm taking x by 2a modulus less than 1. So this is goes outside 1 over 2a. This multiplies, this is a 2a. Okay. Now students, now we check it. How to answer? If we check it, this one, it means highest value is positive 2a and lowest value is negative 2a. And what about this, students? Highest value positive 3a by 2. Or sake of understanding, I make it 1.5. 1.5a positive, negative 1.5a positive. So if I show you the other line here, then you can understand very clearly. Very clearly. There's one line and second line is here. 2a and negative 2a. Now my question is, this is a region for this. And this is a region for this. And what is a common region? Common region, this part is extra. I will not take extra. I will take this part only. So this is my answer. So this is not possible. This is out of range. Actually, this is my in range. So my answer is finally is this, which I tried to satisfy with the diagrammatic explanation. I hope so. The concept of the question is completely clear. Question number 8, topic is proving identities. So left hand side, I'm starting. So cot, what is the cot, students? Cos squared theta over sine squared theta. And tan is a sine square over cos square. If I take LCM, students, what will happen? So sine squared theta into cos squared theta. It multiplies this butterfly method. I get a cos 4 theta and minus sine 4 theta. After this, what to do? You remember formula a square minus b square. This square of a and square of b, you know it very well. So one time what to do? A plus b and one time a minus b. If you multiply these two pairs, you get as this back. So the same rule I'm going to apply it now here. So one time this is a square of cos. This is a square of sine. And denominator, I'm doing no change in denominator. Okay. Sine squared theta, cos squared theta down. So check it, student, this applicable now, this property. So I can say in the numerator what? I'm writing here cos squared theta plus sine squared theta and cos squared theta negative sine squared theta. As I said before, one time plus and one time minus. You see, plus and minus. And down, basically, if you look at carefully, in denominator, we have this one, cosecant. What is the cosecant? Basically 1 by sine. And sine formula, you know, student, we have one more thing, we need 4 also. So sine double theta formula. If you remember, 2 sine theta cos theta. So I have sine, if I take square of both sides, so it becomes sine square double theta. Basically 4 sine squared theta and cos squared theta. This is very clear. So I have a sine square, I have a cos square, but 4 is missing. If 4 is missing, what I'm going to do, multiply top 4 and divide 4, because they will cancel, so no effect will come on question. And this turned to be what? This I'm writing 2 sine theta into cos theta whole square. And this is 1. So basically I got in the numerator cos squared theta and sine squared theta. And down I got sine, this is a sine double theta, double angle, okay? And this power 2 I'm writing on the top here. And we have, the way I have a sine formula, we have a cos as well. Cos, we have a 3 formula basically, but I'm taking the first one which are required here. Cos squared theta minus sine squared theta. Same, the half angle comes here, half angle comes here. So you can see clearly if I have this same thing available on top, it will convert into cos square, no, not square, double theta we got it. And over, we have a two signs. So one sign I'm writing alone and one alone. So here I'm writing, and sorry, I missed 4. I missed this upper 4. I must have it here. I must have it here even. So this 4 we have already. And this sine square we break in two parts. Sine double theta and sine double theta. And 1 we have. And this becomes cot double theta. And become, this is here, I got a cosecant double theta. And that the same is target. And Alhamdulillah Rabbil Alameen, the target is achieved. And we have done, first A part is done. And let's go for part number 2. And maybe on the next page, yes, next page. Next page is asking to solve this one. So first part is connected, so we have to go back and bring the information from back. And what is the information is available here? Basically, if you look at carefully, we have a cot square theta. I'm writing top formula is equals to what? Is equals to this one, which I'm copying paste. Okay. Now, students, I can take this whole expression and cut from here and bring on another page. This will help us to solve the question. So take a look now how to do it. Now look, student, we have proved this from the by part A. By part A. Okay. So if you check it now, what is the comparison? If you compare it, so you see this is fully match. What is the difference? Only in the place of x, he's copying theta. That's it. Remaining same. So it means I'll use the same expression in the place of left side, just theta replaced by x. So we can say that what I can get, so we get from here. What we get from here? I'm writing 4 cot 2x times 2 cosecant 2x is equal to 5 secant 2x. Once again, check it once again. This is replaced by this whole thing, and I copied completely from here, and this 5 secant is still available there. Okay, this done, and now we have to solve it. What is the way to solve it? And 0 to 90 is first quadrant only. We can go first quadrant. So we have to simplify. Cosecant is basically 1 over cos. So I'm writing here 5 over cos double. Okay, cosecant is 1 over sine double. And cot is a cos over sine double. So if it comes this side, multiply up. So it becomes 4 cos square double and down sine square double x equal to 5. And 4 will go on the other side. And cos over sine, I can write cot square double x. If I flip both sides, because cot is 1 by 10 basically, I'll get, students, what? So 10 square double x is equal to 4 upon 5. Take a root of both sides, and I'm getting here 10 double x equal to root of 5 positive and 10 double x negative. So thing is that we have to go on first, because he said that on top quadrant, first quadrant only. So it means we have to take 10 positive is first quadrant and third, and negative is here and here. So here no chance, but double x here. So maybe we'll check it first of all. So what is here? So double x, if I take tan inverse, and he said degree mode. Okay, we have to keep our calculator in degree mode. It is very important. Tan inverse, I have taken this as alpha and tan inverse root 4 over 5 all together. So when I type it, we got alpha 41.8. So 41.8, and this is 40, and he's asking what is pi by 2. Okay, anyway, so we getting here 2x back from here. So I'm writing here 41.8, and we can go for second diagram even available. In second diagram, students, what we have here, okay, second diagram, we have negative sign. So we will take up, because we'll not take negative sign. So same value, 41.8. 41.8 students, we have same, and 41.8. So what is this one? So 180 minus. So I can say 2x equal to 180 minus. So 180 minus 41.8. And when I solve it, 180 minus, I'm getting here 138.2, and divided by 2, it is not crossing, it is in the boundary. We got a 69.1 degree, which is in the boundary. And what about the left hand side, students? 41.8 divided by 2, it is also in the boundary. I'm getting 20.9 degree. So we got two answers. Okay, this answer we can check even 180 plus 41.8. I'm just checking calculator. First of all, 180 plus 41.8 and then divide by 2. But problem is coming 110.9. It's crossing now 90 degrees, so I'm not writing it. And I hope so the concept is very clear. And the question is completely over. Question number 9, topic is vectors. And we have given 3 points, and their position vectors are given OA, OB, and OC. And he's saying that line L passes through BC. So what is the way to do it? It is a very clear. R is equals to, I can do like this. R is equals to B and C. So I'm using OB plus lambda time to BC. So how to get BC? BC is very clear. OC minus OB. OC here, OB here. So 2 minus 1, 3. I took coefficients from here. And OB is 1, 3, and negative 2. Okay, this is a clear. I got a 2 minus 1, 1, negative 4, and 5. So I'm copying the values. OB comes from here. 1, 3, and negative 2. And lambda times 2 BC, which is 1, negative 4, and 5. So this part is clear for 2 marks. Equation of line for L, which passes through BC. Now, students, next part. P is foot of perpendicular from A to L line. A to L line. So, for example, this A coordinates are 1, 1, 1, 2, and 0. Okay, and L line is there. L line, we just got it. 90 degree, and this point is called foot of perpendicular. And he mentioned this P is a foot of perpendicular. This line L. And I'm looking for the P coordinates. What is the technique? So first we convert standard form. So what is standard form? Standard form. Standard form is very important. So when I find standard form, it turns to be lambda multiply inside and add these values. So 1 plus lambda, 3 minus 4 lambda, and negative 2 plus 5 lambda. Okay. And now this, when I convert standard form, it represents million, trillion, every point on the line. We can say this is also OP. So I'm copying it, and I'm labeling I think I label here same here. I'm labeling as here OP. This is OP. Okay. And now, students, what is the plan of action? I'm finding AP dot line direction equal to 0 because 90 degree. Okay, AP. So planning is very simple. AP vector dot B equal to 0. What is the B? AP is this, we can find it inshallah. B is line direction, which is, this is called, after lambda is always called B. So I will find out the dot product, but first of all, I need AP. How to get AP, students? AP. OP minus OA. And OP, again, I'm copying this completely. Save the time. Okay, minus OA, and here is my answer. OA is 120, you can see on top. So 1 minus 1 is cancel, only lambda, and 3 minus 2, 1 minus 4 lambda, and negative 2 and plus 5 lambda. Now, student, as I said you, this is AP value and line direction is where? Line direction is this. So this I'm bringing down. I'm going to plug in 1, negative 4, 5. 1, negative 4, 5 B value, and this value I'm copy and paste once again. And dot product is equal to 0. You know it very well. So corresponding values you will multiply like this, and like this. So I'm getting lambda and negative 4 and plus 16 lambda and negative 10 and plus 25 lambda is equal to 0. So this is clear. So after this, you can find the lambda value, which is a very clear, and lambda value I'm finding now. Lambda value is what? If you check it, lambda 16, 25 and 26, 26 and 16, I'm getting 12, 342 lambda. 42 lambda and negative 14 is equals to 0. So lambda is coming with us. So 14 divided by 42 is turned to be 103. So 103 I'm getting, and this 103 I'm plugging it here. I will get the foot of perpendicular. So OP value I'm getting directly. So 1 by 3, plugging it here. 3 plus 1, 4 over 3. So we are getting 4 over 3. 4 over 3. And now I'm going to plug in this value here. And I can say that, so 3 minus 4 over 3. And we are getting 5 over 3. Okay, then I plug in this value here. What happens, students? Negative 2 and plus 5 over 3. And it's turned to be negative 1 over 3. And we got the foot of perpendicular clearly. So this part is very clear. And let's go for next point. Next part on next page is here. And that is asking for D is a foot, D is a reflection of the line in L. Basically, we found that, let me explain, is line L, and you know it very well. A is on the top, and there's a perpendicular P point. There's a P point, there's A point. Okay, and this is he mentioned clearly that D is a reflection of A. So this is a D coordinate. Okay, A coordinate I'm writing now here, and D coordinate A, B, C, or I can yeah, A, B, C. Okay, no problem. ABC, I can find it. Okay, there's a midpoint behaving, and P coordinate, I just got it. I'm writing that even. So I have to write A coordinates and P coordinates. So go back. A coordinates is 1 to 0, 1 to 0. A coordinates is 1 to 0. P coordinates are in fractions, so we are write it carefully, and which I'm bringing it now from here. So this vector I'm going to copy from here. And I'm bringing on another page. Okay. And here I'm writing. So because this given by him, OP. So basically I'm getting a coordinates of P, 4 by 3, 5 by 3, and negative 1 by 3. And I'm going to use midpoint formula. All of you know what midpoint formula, x1 plus x2 divided by 2. So this 4 by 3 will come here. X1 is this and x2 is this A. So 1 plus A divided by 2. So this 2 multiply 8 by 3 minus 1 is equal to A. And I'm getting here A becomes 5 by 3. So I'm getting the A coordinate. Okay, done. The same way I'm going for to find the other coordinate. So 1 minute, please. So I'm finding one by one all. So y, what is the y? y1 plus y2 divided by 2. So this y is 5 by 3. I'm getting from here. Y1 is 2 and y this b. So 2 plus b divided by 2. 2 5s are 10 over 3 and negative 2. So b value I'm getting here. So out of 10, 6 gone, 4 over 3. And lastly and finally, I'm getting the z value. I'm writing directly now negative 1 over 3 equal to 0 plus c by 2. And c value I'm getting negative 2 over 3. So I hope so you understood very well how I use midpoint formula to get the answer. Okay, and now I'm writing the final form. And final form is what we have, students. He asking OD coordinates. So OD coordinates are 5 by 3, 4 by 3, and negative 2 by 3. So I hope so the concept of the question is completely clear. Question number 10, students, we have topic is differential equations. So let's try to do it. He has given this expression, some values given. Okay, we have to obtain relation x and y, nothing to make subject, not bound. We are not bound. So I'm starting dx multiplying there. So I'm getting sine 4y, sorry, dy is equals to x sine double y sine triple x. So, and we will check it. What is the next part on the next page? Maybe it will help us. He is asking find y value. So it means we have to make a y subject. So anyways, we are not bound because the examiner not bounding us, but I think I will go for sine left side. So this will go this way, and I'm getting here sine 4y over sine double y dy and x sine triple x. Okay. Now, before I start, you know it very well. This sine double. So we know the formula. I'm writing again. So sine double A basically 2 sine A cos A. This half angle here, half angle here. So it means if I have a 4y, then what happens, students? I'm writing on the top and raising this 4y, I'm writing directly. And this value I'm writing directly, what is that? 2 will come automatically, you know very well, and sine double A into cos double A. You may ask to reason because this 4 double half angle here and here, the other way half angles. So I think clear idea. And I can cancel this sine with sine. And I'm getting it here. Now I'm integrating. Now I'm integrating both sides. So when integrating both sides, I'm getting what here? Left side 2 also available. Cos double y, this clear. And right hand side, I have to go for by parts. Reason product multiplying each other. And I'm writing again, I am late, L-A-T-E, late. Top to bottom, top is V, down is U. Exponential e to power x. Trigonometry, sine or cos. Algebra, x or x square. Logarithm, ln, and I stand for inverse function. Right now, I have trigonometry and algebra. So trigonometry is above, so trigonometry is V, algebra is U. So I'm writing U and V. So now, first I write a formula so you can understand. Okay, so you copy integration of V minus a big sign of integral. This dx must be there. Again, V integration, students, into differentiation of U. So this formula is there. Okay, I'm going to apply, but first of all, I'm doing this one. So what is integration of cos? Sine double y and divided by 2 and 2 cancel out. Now applying this by parts. So first of all, you copy integration of sine, which is a negative cos 3x divided by 3. A sine, big in sine integral, bracket starts, bracket ends, dx. Again, this copy paste here because this same integration. So I'm not wasting your time. I'm writing directly negative cos 3x by 3 times to what? A derivative of x, and that is 1. That is 1. So I have done somehow directly, but I think is understandable. Integration of this is this one. You understand? Integration of this is this one, and derivative of u is, x is 1. So this part is very, very clear. Now, we have to continue. How to continue? Students, sign double y here. Negative, I'm writing before, x cos triple x by 3. And negative comes out, negative, negative, positive. 1 and 3 comes out. I get a 1 over 3. Inside, I'm getting cos triple x and dx. So this part is clear. I'm erasing the formula. Now, students, is question done? Not at all. Some parts still left behind. Negative x cos triple x over 3. And what is this integration? Sine triple x and divided by 3. So we have already 1, 3 and one more 9 and plus c. And now, students, we are going to do what? Going to plug in the limits, and limits are available on the top, and we have to use those limits and go back and check it. So limits I'm putting here, x is equals to pi by 12 and y is equal to pi, I think reverse I wrote. See on top, y is equal to pi by 12 and x is equal to pi by 2. Okay, which I'm going to plug in now. So let's see now how we can apply. So when I plug in this pi by 12 here, so it gives us, make sure calculate must be in radian mode. Don't forget it. Okay. And you can check it. And so sine, because when I plug in pi by 12 here, is give you pi by 6. And pi by 6 sine, we know 1/2, we get a half. And same value, now I'm going to plug in by here, pi by 3, sorry. So lot of patience required. Pi by 2, putting it here. So this 3 and 2 are 6, or I'm writing this alone. And what is the other value? Cos 3 times 2, 3 pi by 2. If it's giving us 0, because when I plug in 3 pi by 2 is 0, so no need to waste time. So this is coming with us 0. Okay. And what about this one? This is not 0, because 3 pi by 2 giving us -1. So -1 by 9. And C value, if we check it, oh, sorry, 1 minute, please, is a plus sign. So C value is becoming 1 by 2 and positive 1 by 9. It's coming with us 11 over 18. So C 11 over 18, plug in back here. So I'm writing this full expression, saving the time. So I believe this part is very clear. Okay, I'm erasing and putting C value 11 over 18. So this is clear, students. After this, what to do onwards. So what he's asking for, he is asking for solve differential equation, and this is done. I think this is all over. So we have to go for, I think, next plan, because this equation we got completely and nothing to do extra with this. And yeah, this is done. And next page, what we have, he is asking, next page, is given that this is a y value, and find the value of the values of y when x is 0. So it means I have to plug in x is equal to 0 and get the y value, but y value must be in a first quadrant, very clearly mentioned here. Is okay. And values of y and x must be 0. I'm going to plug in x 0. Okay, so when I plug in x0, students, so when I plug in x0, this one part is done here. So on part number next, when I plug in x0, so here I'm getting sine double y and x0, so full gone, 0. And x0, sine 0 is 0, gone, I got 11 by 18. Sine is positive where? In first quadrant and second quadrant. Okay, and we have to take it radian mode, make sure, and this taken alpha for a while, and sine inverse 11 over 18. When I take 11 over 18 students, so I'm getting here 0.657. Let me check again. 657, correct. So 657. 657. So my first value is what, students? You can see this one, and second is pi minus that. So I'm writing 2y bring back and 0.657, and the second is a pi minus 0.657. And I have to divide by 2 also. So my first answer is coming with me is 0.329. 0.329. What about this, student? Again, 2 will divide the whole. So pi minus 0.657 and divide by 2. The answers turn to be finally 1.24 radians. So I hope so. The concept of the question is completely clear. Question number 11, topic is numerical solutions and with the mix up with a differentiation and integration. I think differentiation, because he asked that maximum point of M, and at maximum point X is A. So it means that I will plug in dy over dx equal to 0, and same time X replaced by A. So let's start. There are two functions multiplying, and rule is u copy v dash, v copy u dash. So root x copy, and what is sine derivative? I'm writing it now here. Then sine double x copy into the derivative other part. And what is here? Sine derivative is cos double x multiplied 2. This 2 come from angle differentiation. And what about this? Half comes down and power become 1 less. I'm putting derivative 0, and same time replace every x by a. A here, 2 root of a cos of 2a. I'm doing directly, but you take one step to simplify and then try it. This is 2 already available in root of x, so root of a, and sine double a. This part is clear. So now this is my job to find it. Ultimately, okay, so let's try to do it. How to get tan? So first of all, this complete one value we have to bring on the other side. So I think so if I bring this here, better. Or I can bring both, anyone, any value, no problem at all. So 2 root of a is equals to 2 root of a cos double a. Double a, you write bracket, or without bracket, no problem. So this multiply there and this comes down. So I'm getting here sine double a over cos double a. And 2 to the 4, and root becomes this one. And sorry to say, I just not write this minus sign here or minus sign there. No problem at all. And I have done it. Tan double a equal to negative 4a. And target is achieved. Okay. Alhamdulillah Rabbil Alameen. Let's next part. He says, show by calculation the answer of a must lie between this. So we need one expression. Two choices we have. This bring here or bring this on the other side. I bring it here. So I'm writing now f of x, f of a, sorry, not x, because a involved. Tan double a positive 4a. Now students, replace every I'm going to copy. I'm replacing 2 times. Okay. Now one time I replace this a. So one time I'm replacing a with a 0.9. You can see mentioned clearly 0.9. 0.9 here and 0.9 here and 0.9 here. And one time 0.95. 0.95. 0.95. Now I'm going to solve it by radian mode. Make sure. So tan 2 times 2.9 and positive 4 times 2.9. And my answer number 1 is negative 0.686. And now second one, I will just say 95 only. And the answer is turned to be positive 0.873. Student, as sign change, just write a statement as sign changes. So root lies between 0.9 and 0.95. So I have given explanation many times, and I will give again. It means with the 0.9 we are getting negative. It means the sense is this, curve is this, and 0.9 is here, and 0.95 is here. With a 0.9 I'm getting negative answer, and with the 0.95 I'm getting positive answer. So I think this is clear, and this point is called the root. I think the point is clear, and let's go for the next part on the next page. Next page we have C part. Show if sequence of values given by iterative formula, this one converges to A. So basically this is called subscripts. So first of all, remove subscripts. Now you may ask one question, is this compulsory write? Not at all. You can remove without writing. And now tan inverse of 4x. Now what to do onwards? This 2 multiplies there. Basically the previous equation I'm going to need to get here. And tan inverse 4x. Now what to do after this? After this, we'll bring tan on the other side, because look, I'm going to show you. Go back and see. We are planning to get this one, or sorry to say, we can say, yeah, same thing, this one, tan. Okay, I just take it and bring on another page. Okay, so we can keep our eye on our target. Okay, so check it now, students. Now I'll bring I bring naturally tan this way. Tan inverse will come here. Sorry to say, so tan we cannot bring before. So I will bring first of all I will bring pi this way, pi this way. Or another choice we have. If I yeah, better to bring tan inverse here and pi x on the other side. So I can say tan inverse 4x and pi minus 2x. Now I can bring tan inverse, because when we bring here alone, keeping angle here, so I will get a tan inverse, become tan. Now students, this is almost achieved, and here we have to apply a fundamental law. What is the fundamental law of the tan? I'm going to show you on the right hand side. Basically, what's the tan formula? I'm writing here, tan A plus B, or A minus B, no problem. So what is the formula? Above tan A, negative sign tan B, and down 1 plus product of tan A into tan B. I'm going to apply, get ready, 4x is as it is. We have tan pi minus tan 2x over 1 plus tan pi into tan x, tan 2x. And tan pi is 0. Tan pi is 0. So this gone, 4x equals to what? This gone, I got negative tan double x. And this 0 full gone, 1 left. So I think clear, and we have done it. So it means that we can say the same statement, and we can say that yes, it converges. Yes, it converges to A. Okay, this is enough. And this, let me erase this line. This line, no need. This was a target to achieve. Okay, clear now. A means part A. Part A means the part A, whatever answer. Now we have to go for what? Use iterative formula to get a 4 DP answer and give each answer 6 SF. 6 DP, sorry. So let's try to do it. So how to start the question? So we have a formula available on top. So I'm using that formula, n plus 1. Okay, formula is available, so I'm using directly from there. So I will replace n value by 1. So what the formula will convert? So when 1 plus 1, it becomes 2. Half pi minus tan inverse. And here we're going to 4x to power x, 4x1. Now, question with us, we don't know x1. When you don't know x1, sometime given, not given, so take the average of these numbers. So 0.9 and 0.95. 0.9 and 0.95. So I'm writing here x, well, 1 is 0.9 and plus 0.95. So I'm getting here 0.925. So I think this part is very clear. Okay. Now what is the next plan, students? We have to replace it. Okay, replace where? This value replace here. So I'm saving my time. I'm just replacing it now here. I'm writing here 0.925. And I'm getting the first x value. So x2 value, I'm typing completely 1 over 2 outside. Inside pi minus 10 inverse. And then 4 times 2.925. And my answer is turned to be 0.917380 because he said 6 dp. 6 dp. Now first I plug in n1, now I'm plugging x2. So what I'm going to do, I think I should take this much full copy and saving the time, copy and paste. Okay. So when I plug in this, so this will convert to here 2 and this number will change as well and here 3. So here when I plug in n2, so I got here 3 here, 3 here, and this value will come in the place of it. So 0.917380. So when I plug in here, I'm getting 0.918425. Now again, I plug in 3 now and I'm pasting once again, saving the time. So here 3, here this number will change. Here I get a 4, sorry. Here 4, here 4, 0.918425. And my answer number next is 0.918281. So he said 4 dp. Check it, is 4 dp match? No, it's still not match. So some difference is there at the fourth digit. So I have to check it once again. I'm putting n4 and same paste the previous equation. Here 5, here 5. So 5 and 5 and 0.918281. So when I plug in, I'm getting 0.918301. Check it, students. Now it is a start matching because rounding 38383. It means one more attempt I have to check it. Last attempt. So this is 6 and this is 6. And let's try to check it. What is 6 value getting? So x6 0.918301. And when I check it, I got a 0.918298. So if round it, we get we're getting answer, X answer, we are getting here, sorry, A answer, 0.9183 because we have observed that this number is 3 and this number is going to 3. So I think enough practice to complete it. And that's it. And paper is completely done. And best of luck for the upcoming exam. And pray for me. Assalamu alaikum wa rahmatullahi wa barakatuh.